So let's take a look at how we put our LED circuit together on the breadboard. First of all, we want to connect the power connection, so that's the 5 volts and the ground connections. You'll want to use a longer jumper wire for these connections because they have further to go. So we can take the ground connection, that's the GND lettering on the Uno, and we want to connect that to the negative side of our breadboard. So remember, on the breadboard, this column of holes is connected together. You'll find that some breadboards, if they're longer, they might have a break here, but on these smaller breadboards, all of these holes are connected together. And so here we've got ground going through the jumper wire to here. So this means that all of this is now a connection to ground. And remember that all of these GND or ground label pins are connected together. So it doesn't actually matter which pin you connect it to, as long as it's got GND. And then I also like to connect the 5 volt line coming from here to the breadboard as well. Now, as it happens in this circuit, we won't actually be using the 5 volt power connection, but it's good to have it there because we will be using that later on. So now we have 5 volts available to us here. Now you'll notice that I used a black jumper lead and a red jumper lead for the ground and 5 volt connections respectively. Now these are fairly standard colours that are used, so it's good habit to get into using colours that other people will recognise what they mean. So for ground, choose a black jumper lead or sometimes a white jumper lead, and then for power use a red one. And then we'll get on to what colours you can use for signals later on. So if we refer back to our circuit image on our slide, we can see that on the left-hand side, the connection goes from ground to one leg of the LED, which is, of course, the shorter leg. So let's take another black jumper cable and connect it on the board from power to one of the rows. Now I'm going to connect it into row 5, so it's in hole A and 5. Now it doesn't matter which one you actually connect it to, but it will probably be helpful if you carry on and put it in the same holes that I do. So we now have a ground connection from our Uno along through the jumper cable, along the column, and then through here, and so now we have a ground connection in this row 5. So next we want to take our LED and connect it. So we know that from our picture of the circuit that we want to have the flat side connected to ground. So that's the side of the LED with the shorter leg. So that's this one here. So we can go ahead and insert that into row 5. Now what we want to do is have the shorter leg on this side of the channel in the middle of the breadboard. So this is the shorter leg, and this is the longer leg which goes across. So this means that there's no connection between those two legs apart from through the top of the LED. So now we can follow our circuit as it is building up from ground, along the jumper wire, along the negative power rail, through this jumper, along row 5, into the LED, through the LED, and then out the other side onto the other side of row 5. So referring back to our slide, we see that once we've got a connection through the LED, the next stage is to connect it to our resistor. Now remember that the 220 ohm resistor is the one that has red, and then brown, and then gold for the tolerance. We can fold the legs of the resistor into a U shape like this, and then we don't need to use a jumper lead to connect it anywhere because we have we can just use the leg of the resistor. So we can plug that into row 5 and then plug the other leg into row 9. Now, unlike the LED, the resistor does not have a correct way or an incorrect way to be inserted into the circuit, so you can put it in whichever way around you like. You will find that as you build more circuits that have resistors in them, that it's a good idea to have the resistors facing in the same way so that it makes it easier to read them and tell which ones are which. So now if we want to trace our connection, we can go from ground through our lead here, through our power rail for ground, and through our jumper, through our LED, along row 5, and then through the resistor into row 9. And so then looking at our picture of the circuit again, we can see that the other leg of the resistor needs to go into pin 13. Now, because pin 13, the connection to pin 13 is a signal line, so it's a line which isn't just power or ground, the value of it depends on what we set the value to in our sketch. We want to use a different color. So in this case, I'm going to use a green jumper wire. And so we can push that into row 9. So the actual color that you use doesn't matter, but it's nice to keep the colors different so that you can you can tell which ones are which when you have more than one pin connected. So it then goes into pin 13, which is here. If you have trouble telling which pin is which, the first two are blank, then you have one labelled AREF, then you have one labelled ground, and then you have pin 13. Or if you're counting up from the bottom, pin 8, pin 9, pin 10, pin 11, pin 12, pin 13. So now we can look at our circuit and see that it goes from ground along the power ground rail, through this jumper, through the LED, along row 5, through the resistor, along row 9, and then through our green jumper into pin 13. And that's a complete circuit. So now when we install our blink sketch again, we can control the LED that's off the board, not just the LED that's on the board. So let's go and take a look at our example blink sketch again.